All right, here I'll practice with you balancing a few different chemical equations and show you the way that I had pointed out when we were discussing this in person. Um, so you take and you find whatever the most complicated species is, and this has 7 atoms and 2 elements, so we'll put a 1 down here. And I'll label these with alphabetical symbols so that you know the order that I did these when you look back. So then I'll balance iron, and there's 3, and then there are 4 oxygens, and I didn't really have to do anything weird with this one. So 3 irons, 4 oxygens, because the number of oxygens was even and O2 is an even number of oxygens, we were good to go with that one. All right, here, I don't think you could argue that this is the most complicated species. It's got 3 different atoms in it, and it's got 1, 2, 3, 4, 5 total atoms. So we'll stake down that this is 1 for now and start balancing the other species. And I usually just look at this formula and then go left to right. So 2 sodiums, and that would be my second step. Let's see what else. 10, there's 1 10 atom, so I put a 1 down there, so I know that I've looked at that. And then oxygens were already look good. 2 oxygens, 2 oxygens. Finally, I just need to balance hydrogen here. So 2 hydrogens, so 2 times this 1 hydrogen gives me 2 hydrogens, and then there's 2 hydrogens here, so I'll put down a 1 just so that I know that I did it. And then this one is totally balanced at this point. Here we would have the most complicated species would be KBr, and I'll put down a 1 there. I'll balance potassiums by putting a 1 over here. And then bromines, I'm going to have to do a 1/2 because I need 1 bromine and Br2 has 2 bromines. So that was my third step, step C. And then to get rid of that, though, because we don't like those having fractional coefficients, I need to multiply everything by 2. And so that gives me 2 potassiums plus Br2 plus 2 KBr of my properly balanced chemical equation there. Here, this is a combustion reaction, and usually there's a pattern that's easy to follow here, is that we balance carbon, hydrogen, and oxygen. So I'll put a 1 here. This is obviously the most complicated species also, so I'll put a 1 there. That means 8 carbons, and that's 18 hydrogens. 9 waters will give me 18 hydrogens, so that's good. And then oxygens right now, I've committed to 16 and 9. So 8 times 2 is 16 plus 9, that's 25. So I need 25 oxygens from O2, so I have to use that fraction again in order to do that. And then now I'm going to have to multiply everything by 2 to clear that. So 2 C8H18 plus 25 O2 goes to 16 CO2s plus 18 H2Os. All right, and the next one, again, I think it's pretty easy to say what's the most complicated. It's this species. I will balance the first element here. Now I'm going to balance the iodines. I need 3, and I2 has 2. I'm going to have to use a fraction again. And then now I'm going to clear that fraction. So 2SB plus 3I2 goes to 2SBI3. Here for F, I think this has 4 atoms, and it has 3 types of atoms, so we'll say this one's the most complex. And I'll put a 1 down there. I'll balance carbon. Carbon only shows up here and here, so I will balance carbon with a 1. Oxygen, and this is something that's usual to do. So oxygen is in 3 places. It often ends up being nicest just to see if an element that's all over the place will just balance out as we balance the other species. So that's what I'm going to do. I want to go to the chlorines, and I need 2 chlorines. See? And then H2O has 2 hydrogens, and 2 HCl's has 2 hydrogens. So I'm going to put a 1 there. And now I'm going to need to check this carefully. So 1 carbon, 1 carbon, 1, 2 oxygens, 1, 2 oxygens, 2 chlorines, 2 chlorines, 2 hydrogens, and I already did oxygen, so that one looks good. Here for G, we got a bunch of choices. So this species, and this species are all the same complexity. They're 3 atoms and they're 2 different elements. And so any of them, it should work out to be the same. So I'll just pick this first one, A, and set that. So I'm going to balance carbon here first. So 1 carbon, that's my second step. I need 2 sulfurs, so I'm going to need a 2 over here, 2 sulfurs. And then finally, let's see what we can do for these oxygens. So 2 oxygens plus 4 oxygens, I need 2 plus 4 gives me 6. 3 plus 2 gives me 6. So, all right, now let's see if this is still balanced. 1 carbon, 1 carbon, 2 sulfurs, 2 sulfurs, 6 oxygens, 2 plus 4, 6 oxygens. So that one balanced itself out. Here again, we got several that we could choose from. I'm going to just choose this one. Say it's the most complex species. I'm going to balance hydrogens. So 2 hydrogens and 2 hydrogens. 1 sulfur and 1 sulfur. 4 oxygens and 4 oxygens, so that's still good. I've run out of species here. Let's see, 2 sodiums. So 1 times 2 gives me 2 sodiums, so I need 2 sodiums over here. And then there's 2 CNs here, 2 CN minus, that's the cyanide polyatomic anion, CN minus. So this looks balanced now. 2 hydrogens, 2 hydrogens, 1 sulfur, 1 sulfur, 4 oxygens, 4 oxygens, 2 sodiums, 2 sodiums, 2 cyanides, and 2 cyanides. So I've staked my claim on there being 1 potassium and 1 chloride. So I'll say that there's a 1 here. And I need 3 out of something that has 2, so I'm going to have to do that whole fraction thing again. And then I'm going to have to clear the fraction again. 2 KClO3 reacts to give 2 KCl plus 3 O2s. All right, and we're to our last one here. So I'll just say this one's the most complicated species. So 1 barium, 1 barium. There's 2 chlorides, so I need 2 chlorides. 2 potassium, so I'm going to need 2 potassiums. And we have 2 iodates here and 2 iodates here. I'll remind you again, so this is one of those polyatomics. IO3 minus, it's a polyatomic anion, which is here and here. So this one now is also properly balanced.